We continue our exponents quiz review, starting with problem number 9 in this video. Every time we simplify these expressions, we are simplifying and making sure we have only positive exponents in our answers. So problem number 9, I have 15x to the 5th over negative 3x. So I can simplify my coefficients. 15 divided by negative 3 is negative 5. And if I use my algorithm, I know that my variables will be x to the 5th minus 1. X to the 5 minus 1, because that invisible exponent on that x is just a single positive 1. This equals negative 5 to the times x to the 4th power. If you want to solve this by expanding, 15 divided by negative 3 is still negative 5, and you can think about your x's. You would have x times x times x times x times x in your numerator. That's x to the 5th. And you would just have one single x in the denominator. So x divided by x is just 1. You've gotten rid of one x in the numerator, one x in the denominator, and you're left with 1, 2, 3, 4 x's in the top. So that equals negative 5 times x to the 4th power, as we found before. Here, when I have a to the 3rd to the power of 3, all over negative a squared, I have to follow GEMDAS. GEMDAS tells me that I have to find some groupings, then deal with exponents, then I get to multiply and divide, and then I get to add and subtract. That's my order of operations. So here I have to deal with my outer exponent first, and our rule says that we multiply the outer exponent times any exponents we can find on the factors inside. So this is going to be a to the positive 9, still divided by negative a squared. So I will remind you that when we have no visible coefficient, the coefficient is really 1. So this is 1a to the 9th. This is really negative 1a squared in the denominator. So I know that my coefficients are 1 divided by negative 1. Okay, 1 divided by negative 1 is just negative 1. A to the 9 over a to the 2 is going to be a to the 9 minus 2. You take your numerator's exponent and subtract your denominator's exponent. So we have negative a to the 7. 9 minus 2 is 7. Okay, looking here at problem 11. I'll simplify this if I can. So I have 4 over negative 2. I have c squared over c cubed. I have d cubed. I have a negative c over 2c. I have d to the 4th over d. So to work through this problem, I don't have any groupings, and I don't have any outer exponents to deal with. So I can multiply all of my numbers together, or I can start simplifying my exponents. I'm going to start by simplifying my exponents. I will do this problem more than once. I have 4c squared d cubed all over negative 2c cubed. Actually, maybe I'll write this all out on one fraction bar first. I'll multiply my coefficients. 4 times negative 1 in the numerator is going to be negative 4. Remember, this is negative 1 right here. C squared times c, that has an invisible 1. C squared times c, I keep my base and I add my exponents. 2 plus 1 is 3. D cubed times d to the 4th, I'll keep my base and add those exponents. 3 plus 4 is 7. In the denominator, I can multiply these coefficients. Negative 2 times positive 2 is negative 4. C cubed times c to the invisible 1 is going to be, keep my base c, add 3 plus 1, I have 4, and then d just stays d. This is d to the positive 1 if I want to see an exponent. So now, when I want to simplify this problem, I can say negative 4 divided by negative 4 is just 1. A negative divided by a negative is a positive. And I can say c to the 3rd over c to the 4th. If I want to remember that my larger exponent is that 4, I can have my final answer record c in the denominator, 4 minus 3 is just 1. D to the 7th over d to the power of 1. 7 is my larger exponent, so I'll keep my answer in the numerator here. And then 7 minus 1 is 6, so I have d to the 6. So that should be my answer, d to the 6 over c.